Hello and welcome to this webinar where we'll introduce Peltarion and demonstrate the main capabilities of our operational AI platform. I'm Tomas Karlsson and I'm the Enablement Manager. At Peltarion, we believe that AI has the potential to dramatically change the world around us, and our approach is based on the combined experience of a data science team who have been leading deep learning projects for over 15 years. The result is our operational AI platform that enables quick creation and seamless deployment of commercially viable AI applications. The platform is cloud-based and has an intuitive and collaborative interface that provides an end-to-end workflow throughout entire AI projects, from data management and model creation to training and deployment. We believe that there's massive opportunities for companies that aim to operationalize AI as a core part of their business. Most organizations, however, face several challenges that prevent them from moving to successfully integrating AI in their business. This includes that it's hard to find the right talent and resources to run AI projects, and that there's a lack of software solutions which truly support a business across a broad range of AI use cases. A necessary condition to deliver successful deep learning projects is having skilled and capable data scientists who have a good grasp of deep learning and are competent with the current research software tools, and also need to have a strong understanding of the business context that they're working in. These individuals are very hard to find, which has led to a situation with intense competition between companies to recruit the best talents. Active support to the education system to help bridge this skills gap is one solution, but we also need to enable a wider group of users, such as more junior level data scientists and developers, to take on more challenging AI tasks, including in deep learning. Businesses also face a number of software delivery challenges that prevent them from fully harnessing the power of AI. Many deep learning tools are very complex to use and are also not suited for the transitioning of models from a prototype environment to live IT environments. Deep learning projects require access to specialized hardware that needs advanced configuration to run training code, and the setup of these machines can be a daunting task even for an experienced data scientist. These challenges lead to a situation where tools are either too complex to be manageable or built with too basic functionality to render meaningful results, effectively preventing businesses from leveraging AI. Peltarion's mission is to help solve these challenges, which has prompted us to build the first operational AI platform that provides an end-to-end workflow to efficiently develop and deploy AI applications. Our aim has been to build a platform that is easy to use through an intuitive interface that enables more users to work on AI projects and speeds up the modeling cycle. The platform also supports a number of data formats, AI techniques, and is hardware independent. We know that collaboration is a key factor to success of any AI project and have therefore included strong project management and reporting tools. So how does all of this work? Well, the starting point is having access to the right data and defining methods for capturing, storing, and preparing it. Once that is in place, the data is transferred to the Peltarion platform, where it's taken through an iterative workflow from data preparation to model building within minutes. We can run and evaluate multiple experiments in parallel, and deploying the model is easy as it's accessed via an endpoint and API. Underlying this workflow are some key administrative features, including project management functionality to facilitate collaboration between team members and across projects, detailed reporting on KPIs and resource allocation, as well as access control by assigning team roles and permission levels. As a next step, we would like to show you how this works live by going through one of our tutorials called Deploy an Operational AI Model. This demo will show you the key capabilities of the platform by solving a classification problem and building an operational AI model that predicts a label. To do this, we will use the classic MNIST dataset, which consists of 60,000 images of handwritten digits. And the challenge for our model will be to predict what digit has been written on any given image. We'll start by creating a new project. Click the New Project button, give the project a name, and then click Submit. This now adds the project to your list of available projects, and we can select it to see a short description and open it. Navigate to the Dataset view to import the dataset by clicking the New Dataset button. Choose the Upload Files tab if you want to drag and drop the file or upload from your computer, or choose the Import Files tab if you prefer to enter a URL to a public data file. You will find the MNIST dataset that we're using for this example in the tutorial section in the Knowledge Center. Once the file import is complete, click Next, give the file a name, and let's call it MNIST in this case, and then click Done. The platform now adds the dataset to the datasets area, displaying one column for each feature, in our case, images and numbers. Before starting our experiment, we need to prepare the dataset, and we will start by setting the encoding for the number to categorical. In our dataset, we have numbers ranging from 0 to 9, but we do not want to impose a specific ordering on these categories. In other words, we don't want our model to associate higher numbers with a better label, which the categorical encoding ensures. On the right-hand side, you will also notice that the platform by default splits the dataset into two subsets. 80% will be included in the training subset, and 20% is put aside for a validation subset. We use the validation subsets to validate that the trained model will also work on unknown data. As a side note, I should mention that you can adjust these settings manually to split the dataset based on your model. You can also add further subsets, like for example a test subset, by clicking the new subset button. In our example, we will stay with the standard settings, and next let's save this version of the dataset before we move on to the modeling view. There's no limits to how we build the AI model. We can build it from scratch by adding block by block to the modeling canvas, or selecting from a series of preloaded templates. In this example, we will use a template and add a complete convolutional neural network, which is often used to solve image classification problems. We'll start by creating a new experiment, and then navigating to the block section and choosing the snippets. Choose the CNN snippet and add the convolutional neural network to the canvas. You may also notice that we have a number of other snippets available in the platform. These are curated, best-in-class deep learning frameworks and allow you to quickly run different experiments and test different models. Once a model has been added to the modeling canvas, the platform helps guide us through the process of changing the settings through these pop-up windows. And as you see in our example, it's telling me that the first step here is to select an input and select a feature for that. We will choose our images as input, and then the next step is to select the target, which in our case will be the numbers, since we obviously want our model to predict which number is displayed in any given image. And now we've already built our first model. You can tweak the settings in the settings tab, for example, change the batch size, the number of epochs we want to run in this training, and optimizers and several other parameters. But for this example, we will stay with the standard settings and then next click the Run button to start our experiment. In the evaluation view, we can see real-time how the AI model is performing as it's learning from the data. The platform has a number of methods of analyzing experiment results. Review the loss curve to see the magnitude of error the model made on its prediction. As a general rule, the loss is lower for a model with a strong prediction. The confusion matrix below it shows the kind of errors a classification model is making. The values in the diagonal should be higher than the rest of the table for a good model. You can at any time pause a running experiment by choosing it and clicking the pause button, and then go back to adjust the parameters. Another key feature of the Peltarion platform is the possibility to run multiple experiments in parallel to evaluate the best fitting one. And you can search for the different experiments you have running in the left-hand side navigation bar. For the sake of this demo, we will settle with the results that this model is giving us and move to the deployment view to push our model into production. Click New Deployment, select the experiment that you want to deploy, and then you can also choose which checkpoint to use, either the best fitting epoch or the last run epoch, and then click Create. Next, click the Enable button in the top right-hand corner to confirm that you want to deploy the model. This gives us an endpoint URL, which is used to call the API by sending an HTTP post. The token below it is required to authenticate the calls. And as a final step, let's test our model. We have built an image classifier tester, which we will use to test our model in this case. Open the image classifier tester, which you will find in our Knowledge Center, and copy the URL and token from the platform deployment view. Set image parameter to image, width to 28 and height to 28, as these are the sizes of our images. And as a next step, we'll write a digit on a piece of paper and take a photo of it that we'll scan and upload to the image classifier. And now let's test to see if the model recognizes which digit this is. And that concludes this tutorial, where we have walked through the steps of building an operational model that can be put into production straight away. As you can see, the platform is designed to support fast modeling and deployment of AI models based on deep learning techniques. The Peltarion team has over 15 years of experience and knowledge of solving deep learning problems, which we have infused into our platform. Peltarion's technology is already being used by over 300 customers across a number of industries, including healthcare, finance, and entertainment. And now it's your turn. Experience the power of the Peltarion platform yourself by signing up for our community edition, which is available free of charge and lets you get started building your own operational AI models. We have put together comprehensive enablement resources, including detailed product descriptions, a searchable help section, and end-to-end tutorials in our knowledge center that will support you in building your AI models. Thank you for watching this webinar, and we look forward to seeing how you will innovate in the AI space.